All right, so good morning once again, Aviatrix certified engineers. This is Sadners, and I'm joined with Shazad Ali.
Hi guys, good to see you all here.
So together we'll be sharing the exciting new features of Aviatrix Transit today. So here are some of the features Shazad and I will cover today, right? So none of these features are available in any native transit solution. So let's talk about what these are in, for example, the brand new UI, right? Once you log into the Aviatrix controller 6.0, you will see a fresh look UI. It cannot go unnoticed, right? The big one is the ActiveMesh 2.0. What is that, right? You guys have already been using the ActiveMesh 1.0. This is to provide you more control in terms of traffic engineering and stuff. The third one is also a big one, which is a multi-region, multi-cloud network segmentation. This is your cloud segmentation. Basically, that works across multiple region, multiple cloud. For example, let's take a look at it over here. You have the green VPCs, you have blue VPCs, and you also have your on-prem environment, which is like in green color right now, which is in green segment. So now, if you look at that, um, most probably you guys might have already been using the security domains concept in your prior 6.0 release. So we are extending the same concept in 6.0, but this time in multi-region, multi-cloud environment, and also extending towards the on-prem too. So if you have a connection policy between your AWS and GCP world, between two different segments here, the green segment and the blue segment, then even from the on-prem, you have access to those. So that is a power which Aviatrix is providing you for the multi-region, multi-cloud customers. And I really don't want to steal the thunder of Shazad, and I'll let Shazad talk about this, multi-region, multi-cloud network segmentation in detail. We will also talk about the Azure multi-AZ support, which is the high availability support provided by the Aviatrix. Then over here, the GCP multi-region transit, another exciting feature for GCP customers to put the native basically on steroids, right? From the security perspective, a lot of enhancements and new features related to security, like multi-firenet, like which is a dual firenet functionality for various design scenarios. And we will talk about this thing in detail, how you can utilize that functionality as well. Another important one is the network correctness. We talked about this thing a lot. We'll show you what do we mean by network correctness. Basically providing you the control. So no partner or any branch can bring your entire network down. Also, what's new with overlapping IP support? There are already ways, for example, if you have the overlapping IPs on these VPCs over here, natively, there is no way you can provide the connectivity between them. With Aviatrix, yes, you can do that. But now we are even enhancing this thing in site to cloud world, and we will show you how we do that. Last but not least, a lot of new enhancements with infrastructure as code and visibility. And we'll talk about all those. So let's get this started, right? So the first one is the brand new UI. So let me take you over there and show you the fresh new look of the UI. So right away, once you look at this, it just cannot go unnoticed, right? It's a fresh look, everything is arranged in much better way. And then you will see here that there is definitely going to be resemblance. Like the left pane is going to have all your features over here. There is a multi-cloud transit. Under the multi-cloud transit, you can configure your transit peering, your FireNet, and all those kind of things. Those things is still going to be there. The UI load time is going to be much improved this time. Also, we are providing you the flexibility in terms of how you are going to arrange your UI. For example, there are certain features in the gateway and you wanted to make sure you wanted to see only those gateways with certain features. You can select all those and then it's going to remain sticky in your environment. So you can click back and forth anywhere, come back, and then those features will be sticky. So a lot of good enhancements into the UI. I'm pretty sure you guys are going to love this 6.0 UI. Okay, so let's talk about the ActiveMesh 2.0. So I'm pretty sure you guys have already been using the ActiveMesh 1.0. What ActiveMesh 1.0 provides you? It provides you the high availability, redundancy in terms of the Aviatrix gateways, whether they are sitting in the spoke or whether they are sitting in the transit, right? So now what this Aviatrix ActiveMesh 2.0 is doing, it's providing you deterministic next hop selection based on the path selection algorithm. But before we even talked about the path selection algorithm, let's talk about it, how Aviatrix transit gateways are going to classify the routes which is receiving from different sources. For example, if there is a TGW, which is a native AWS construct, and then there is a VPC attached to it, when you attach a VPC, you are going to get a route, which is the VPC CIDR. How we are going to classify it. So with ActiveMesh 2.0, we are going to classify this thing as a local route. Same thing with all the spoke routes. If we are receiving the spoke routes, which are behind the Aviatrix spoke gateways, we are also going to consider them as local routes. So similar to the AWS world, the Azure world works pretty much the same way. If you have attached your VNet with the native VNet peering, then Aviatrix Transit Gateway is sitting in the Transit VNet is going to consider those spoke VNet routes as the local routes. Okay? And if you have a IPsec connectivity, the IPsec BGP connectivity with the on-prem, using the TGW. At that point, this is going to be considered as just a regular BGP route. And same thing if you are receiving the routes through the DX gateway. So no change in there. Okay, so what about between the two transits? So transit of any region, any cloud, when you're receiving the routes from each other, those routes are going to be considered as normal BGP routes. Okay, if you have a cloud and devices on-prem, even those routes we are going to consider as a normal BGP routes over here. But the routes which we are receiving using the static configuration, and even though there is a connectivity to site to cloud connectivity with any branch or on-prem environment, but this connectivity, this IPsec is built on the static route, then this route is going to be considered as a local route here. All right, so what about the transit VPC or VNet address space or CIDR? Everything like in this picture, I'm showing you 1.1.1.0/8, that is also considered as a local route over here. So whether it's setting the VPC or VNet, it's basically the same thing. Okay, and if you have enabled egress through your firewall, the vendor of your choice, Checkpoint, Palo Alto, Fortinet, any of the vendor, right? If you have enabled the egress to the firewall, basically what you are doing, you're injecting a quad zero route. That quad zero route is now going to be considered as a local route for this particular transit. And at the end, we are saying if you have enabled the source net on any of the transit gateways, then that source net address is also going to be considered as a local route. So what is the difference between the local route and the BGP learn route? Basically, the local routes has higher priority, and that's how the algorithm is going to work. So let's take a look at it, how the algorithm is going to work. So first one, as I just talked about it, the local has high priority. And then if we are now talking about the BGP learn routes, then the shortest AS path length is going to win. So if you're receiving two BGP routes with different types of AS path length, one route with AS path length of 2 and the second route with AS path length of 3, then AS path length of 2 is obviously going to win in this route selection algorithm. But what about even if you have the two routes with the same AS path length? What is going to happen at that point? At that point, the tiebreaker is going to be a lowest metric. So whichever route is we are receiving from my neighbor, then we are going to check the metric value, what metric value they are advertising. If they are advertising with different metric value, then we are going to pick the metric value, the lowest metric value, and install that route in the transit gateways. Okay, so what about if you have the same AS path length and my neighbor is advertising with the same metric value? What is going to happen at that point? Then it comes down onto the ECMP toggle, right? So what is this ECMP toggle? By default, we have to understand that ECMP is disabled by default, right? And then if you are receiving the same route from two different neighbors, then with the same metric and AS path length, then the tiebreaker is going to be the lower integer IP next hop. So if you are receiving the same route from two different neighbors and two different neighbor IP addresses are 10.1.1.10 and 10.1.1.20, and if you receive the same route at the same time, then we are going to prefer 10.1.1.10 route because that has the lower integer IP next hop. That makes sense. But what about this piece which I just wrote over here? This best route existing connection. It means sometimes what happens when we are configuring this thing on-prem, then we end up applying the configuration on one router first, and then we apply the configuration on the second router. So if we happen to apply the configuration on the 10.1.1.20 router first, then at that point, Aviatrix gateways is not going to change the best route selection because it already received the best route, even though the integer of the next hop is higher, we are going to keep it as is. And the reason why, because we really don't want to disturb any traffic. But if we are going to receive the same route at the same time, then at that point, we are going to use the lower integer IP next hop value. Okay, so what about if the ECMP is enabled? At that point, this is a desired state or desired thing which you wanted in your environment. At that point, the traffic is going to be distributed to available routes over there. So it's pretty easy, like how this whole route selection algorithm works. Now let's put this thing into perspective, like how this whole thing actually works. So let's take a look at this example. In this topology, what I'm showing you, the Azure and AWS. On the left-hand side, there is an Azure environment with Azure Express Route connecting the on-prem to the cloud. The on-prem environment has an ASN of 65,000, and then the Azure Transit Gateways, which are the Aviatrix Transit Gateways, they have the ASN of 65,010. While AWS has the direct connectivity also through the private connection. They have the ASN of 65,001, and then the transit gateways of the AWS, which is the Aviatrix transit gateways, they have the ASN value of 65,020. If you are advertising the same route, which is usually a very typical scenario where enterprises are advertising the same route from two different data centers, and I'm showing you exactly the same scenario here. So 10/8 is being advertised from both sides. In that scenario, let's take a look at the example of the Azure. In Azure, when this route is received on the transit gateways is receiving this route from two different sources. One is from on-prem with the AS path length of 1, while the same route is being received from its transit peer across the multi-cloud environment through this link, right? And this link, we are receiving it, but this time we are receiving it through two AS path length, right? AS path length of 2 basically. So which one we are going to prefer? Obviously, according to the algorithm, we are going to prefer the on-prem route, which is received directly from here. But there are some scenarios where you wanted to prefer the multi-cloud route rather than the on-prem route. In that kind of scenario, what you have to do, you have to add the ASN over here. You have to just increase the ASN length over there from the on-prem and advertise it that way. So at that point, when we are going to receive the route, like the Aviatrix transit gateways are going to receive the route, this time it's going to prefer the route from its neighbor, because the 10/8 route is received with the length of 2, while the on-prem route is received with the length of 3. So you can see there is a lot of deterministic approach in this ActiveMesh 2.0 over here. Since I've been talking about a lot about the ECMP, so let's talk about it, what enhancements we have made. First of all, how you enable the ECMP. It's extremely easy, just a single toggle switch over here, which you can see under the multi-cloud transit, under the advanced section. All you have to do is to just select your transit gateway and enable BGP ECMP. Remember, the ECMP is disabled by default. Once you enable this ECMP, it is going to be enabled on both the transit gateways at the same time. Select your primary and the HA, both at the same time. So there is no box by box level of configuration required in this scenario, right? So now let's take a look at how does it work. As you guys already know, we utilize the AZ affinity. For example, this workload, which is sitting in this spoke, if this workload is sitting in availability zone A, we are always going to forward the traffic to the primary gateway, which is sitting in that particular availability zone, right? For example, in this scenario, we are going to send the traffic over to this gateway, which is in the same availability zone as this workload. From between the spoke and then the transit gateways, the traffic is always going to be ECMP, right? This is the ActiveMesh by default, right? Now, in this scenario, since ECMP is enabled, then we have to look at what is the behavior of the transit gateways, what they are going to do. So let's take a look at it. If ECMP is enabled, the traffic is going to be forwarded to all the available paths to this transit gateways here. So this could be not desired sometimes in the scenarios like the one which I'm showing you right now. For example, if you have the on-prem firewalls in conjunction with the firewalls in the cloud, then at that point, these firewalls may not get the symmetrical routing, right? Symmetrical path, basically. So at that point, the firewall is going to break. So what you have to do, you have to actually disable the ECMP in those kind of scenario. Once you disable the ECMP, the traffic is still going to come to both transit gateways, but this time, the transit gateways is going to prefer only its primary path, right, towards this primary gateway. And the traffic is going to go through the firewall, and firewall is going to maintain its, basically, its symmetry. All right, so this is about the ActiveMesh 2.0 preview, right? Let's talk about some other features like the Azure multi-AZ support. So what this Azure multi-AZ support is, it's basically to provide the AZ level high availability. Wherever Azure is providing you the AZ level availability, now you can deploy the Aviatrix gateway in those availability zones. And it doesn't matter whether you are doing this thing for the spoke gateways or the transit gateways. So this multi-availability zone support is available for both the spoke gateways as well as the transit VNet gateways as well. In terms of the GCP, a GCP, like the GCP multi-region transit, right? So everybody plays to their strength. GCP strength is the global VPCs. So they say, okay, so you need to create a global VPC, and that is available across the regions for you. So it doesn't matter where you created it, it's going to be available everywhere. So now with Aviatrix GCP multi-region transit functionality, you can utilize the multi-region level high availability. So gateways can be installed across the multiple regions, right? And those regions could be across the globe too. And by the way, this functionality is available for both spokes and the transits, right? So in this picture, what we're showing you two different GCP projects, GCP Project 1 and GCP Project 2, and it works exactly the same way across any regions in GCP. A very cool feature. A lot of GCP customers actually loves this. Okay, so now let's talk about the network correctness and site to cloud. What enhancements we have made in 6.0, right? So first, let's talk about the network correctness first, right? Even for network correctness, what about the route approval, right? In this topology, you have AWS on the left-hand side, Azure on the right-hand side. Again, there is a hybrid connectivity from the on-prem environment, and somebody from the on-prem of the Azure, they are sending a quad 0 route. So that somebody could be your on-prem IT. Maybe that guy has access, or maybe that guy has approved this quad 0 route to be injected into the cloud environment or not. You don't know, right? So, but this route is being advertised through the BGP. Once this route is being advertised through the BGP, then route is going to get to the transit gateways sitting in the transit VNet of the Azure Region 1. Now what this transit gateway is going to do, they are going to notify the Aviatrix controller. Hey, I have received a quad 0 route. What should I do? The Aviatrix controller is going to notify the admin. By the way, we have received this route. What do you want to do? The admin, if this is a legit route, which is already approved, then what this admin is going to do, this admin is going to just say, yes, this is all good. I'm approving it. You go ahead and install this on basically on all the spokes. So this is basically providing you the control and the flexibility and actually the power. So now no partner, no branch is going to melt down your entire cloud environment, basically. Okay, so in terms of the overlapping IP support, you guys already know, like, we have the overlapping IP support, but there is some enhancement. Now, if a branch is connected to using the site to cloud to any of the VPCs where this particular Linux server is trying to access the environment or maybe access the resources sitting in that particular VPC. So basically what happens over there, right? So usually what happens, the developers goes first into the cloud, right? And then they actually pick any of the CIDRs or addresses space, whatever they like, because they don't know what's the on-prem cloud, on-prem IT is being using. But once the on-prem IT goes into the cloud, then they notice that, hey, the developers are already using it, but it's already too late because neither the developer can change their IP space nor the on-prem IT can change it. At that point, you are in a big trouble. So this feature is going to help you. So let's actually zoom in this VPC and see what's inside there and what kind of configuration is required. So here, you see this particular instance has an IP of 10.10.1.5 in the same CIDR 10.10.00/20 as the on-prem environment, 10.10.00/20. So this is an overlapping IP scenario. With this particular feature, what you have to do, you have to create two ghost subnets basically in here, provided that is going to be the same subnet mask as the VPC CIDR or the VNet's addresses space subnet mask, right? So source virtual CIDR, we are saying it's can be 172.16.00/20. Destination could be 192.168.00/20. So here, by doing something like this, you are creating a single source NAT or DNAT rule on transit Aviatrix gateways over here. So just a single rule, and you don't have to create no configuration required on-prem, right? This is huge because most of the time, either you don't have control on this router, or maybe it's going to take a lot of time to get the approval to do anything in the on-prem world. So everything is done right in the cloud and on Aviatrix gateways with a single rule. So if you have a single Linux server, or maybe tens of Linux servers sitting on-prem, they all can get benefit using the single rule over here. So this is a huge feature. Okay, so now let's go back to the network correctness. Now I want to talk about in terms of some of the native capability for the network correctness, right? So what about when the route is being propagated, and this time the route is non-RFC 1918 routes? And most of you guys agree with me the fact that the cloud IT and then the on-prem IT, most of the time they are not in sync, right? So there is always some kind of miscommunication. The on-prem IT thinks they have already communicated that they are going to inject a route, while the cloud IT never got the memo, and they never add the static routes back to the spoke VPCs. For example, in this scenario, this non-RFC 1918 route is being propagated to the TGW, but it sits over here because the cloud IT never went ahead and installed those routes, those static routes over here in those spoke VPCs. So the communication with the non-RFC 1918 application is going to be broken. With the Aviatrix controller, when you have deployed this entire solution with the Aviatrix controller, we take this thing and we are going to provide this network correctness as well. As soon as we receive the route, we will make sure that non-RFC 1918 route is going to be advertised to all those spoke VPCs, provided this is the policy which you have created. So what about in the native world, right? In the native world, when you attach the VPCs to the TGW learns a route, but that route never gets propagated back to the spokes. And Aviatrix controller does that thing for you as well, right? All right, so let's now go back and talk about the infrastructure as code and visibility. Okay, in the previous ACE session, which is also a preview for you guys, we did a Copilot, preview. We showed you a lot of features which Copilot currently has, and now Copilot has introduced a lot of new features. For example, in the filtering field, right now here, what I did, I'm filtering the transit gateways. So what it's going to do, it's not going to remove everything from your topology view. It's going to keep everything in your topology view, but going to highlight all the transit, like with this, light green highlight around this transit gateways. So wherever you see the transit gateway, there will be some highlights. So it's going to make it really easy for you to find out which one are your transit, and also going to help you with the entire overall topology. Not only that, but also for those applications which are latency sensitive. For those latency sensitive applications, you wanted to make sure that latency is not above a certain threshold. For example, if you have a multi-cloud environment, like the one I'm showing you right now, is between the Azure South Central region and then the Oregon AWS region, I am seeing around 80 milliseconds of latency, right? This, you can enable it using the Copilot now. So if your application cannot sustain a latency of more than 50 milliseconds, that is a big problem, and that's why your application is not working properly. So this is something which we are providing you in this release as well. So you can enable it per link basis. So this latency is available between the transit and also between the transit and the spoke as well. Even though this is a small lab topology which I'm using, this is still a multi-cloud environment, a GCP, Azure, and then AWS. Even for all that, in this multi-cloud environment, you really don't have to learn all the different ways like the native programming languages over here. You don't need to learn about the PowerShell scripts or cloud formation templates or Terraform of the GCP or anything. All you have to do is for your multi-cloud environment, you have to learn a single Terraform, which is the Aviatrix Terraform. And then we are going to do the translation on your behalf to all these different GCP environments. So that's all I have, and I'm going to hand it over to Shazad. Shazad, you ready? If I just go ahead and
Yep,
okay.
I'm ready, sir.
Give me 1 second to unshare. You go ahead and please share this.
All right. Can you guys see my screen here?
Yes, Shazad.
All right. Thank you, guys. Thank you, Saad. Was a great preview of 6.0 features. So now I'm going to go dive into this multi-cloud network segmentation. So you guys know that when it comes to building your multi-cloud network architecture in the cloud, you have different type of workload running in the cloud. So you have the prod, dev, and test. And also you need to make sure that you're providing the proper compliance and auditing for the workload, right? So these cloud providers, the native tools that they provide you, they don't give you this capability to color the traffic or segment the traffic properly. So this is where Aviatrix is helping customers segment the traffic based on the type of workload you have in the cloud. And the beauty of this solution is that this is not just for one single cloud. This is actually available globally to multiple clouds. Could be GCP, could be AWS or Azure. So what you can do, you can actually color your traffic. So in this architecture, the multi-cloud network architecture, you can see I have different type of workloads. So I have some green, I have some blue, and then this purple is shared services. So what I'm gonna do, I can actually color them based on their traffic profile. And I created this blue segment, and then I created this green segments. Now you notice that these segments are actually available across different cloud. And not only that, I'm also taking into account the on-prem connectivity that you have. Could be through Direct Connect, could be through Express Route, or you could have some site to cloud connections coming into Aviatrix Transit. So this allows customers or enterprises to create these network segmentations and policy-based security control across multiple regions, multiple clouds, or even if you're in single cloud, this is still applicable, right? And a lot of time I have also seen that when they are trying to figure out how to segment the traffic, they are utilizing sometimes the security groups or NSGs, and they are fighting or struggling to find the accounts and subscriptions so that they can create those security constructs. So that's not the problem here, because with the help of Aviatrix centralized control plane, we are realizing this from a central location. And the application or realization is happening at the distributed data plane that we have, what you see, the red circles, the Aviatrix gateways. Now, in my case here, I have created these segments, and what I'm gonna do is a very simple workflow, just single point and click workflow in the controller, or could be a single Terraform, where you create the segments, and then with the help of connection policies, you can now write your security policies. And with that, you can see I have created this policy to allow traffic between green segments and blue segment here. And then for shared services, I have another policy which allows me to connect my shared services resources to the green segment. Right, so what exactly is happening here? The way we are helping our customers and enterprises is that we are providing this security posture that they can create for their applications within a minute. It's being realized through Aviatrix control plane. You can create zero trust based model where you don't allow all communication or any communication, but you select the type of communication you want to happen. It is extremely flexible. You could have only one AWS cloud or GCP or Azure, or even a single region or multiple region. This is applicable in all those situations. And it's all automated through our Aviatrix centralized control plane and the data plane realization that we have. The security, as you guys know, is something you need to cater in multiple layers. It's not just, you know, a unidirectional approach you need to take care of, right? So this is also important that this whole thing, the multi-cloud network segmentation, plugs into our MCNA architecture. So you have it running with all the other features that Saad mentioned before. And also the compliance, when it comes to compliance, you can see this high performance encryption here, which allows you to connect to your data center resources using the line rate performance. Because these cloud constructs or cloud native IPsec, if you wanna call it, only gives you the 1.25 GB bandwidth or throughput on this IPsec link. With the help of Aviatrix high performance encryption, we are actually allowing you to not only protect this using the network segmentation, but also allowing you to protect this using the high performance encryption that we have. Okay, so we talked about the network segmentation. Let's take a look at another challenge which a lot of customers have when it comes to deploying the firewalls or security appliances in the cloud, right? So I'll give you the example of bank. When you go into the bank, you see they have the security at the door. So they have the heat sensor, they have the motion sensor, and then there is a level of physical security as well. But when you enter into the bank, then you are going to go through additional layers of security. And then there is a vault, which is the most protected security place you have in the bank. So similar concept here applies in the data center or multi-cloud network architecture, where you're providing the security through encryption, through security segmentation, through network segmentation. Or when it comes to protecting your most secure workload, now you need to have maybe next generation firewall or some security appliance so that you can do deep packet inspection, threat prevention, or IPS or IDS type functionality. So when you're about to deploy this using the cloud native constructs, you are again running into so many challenges. There is a challenge of manual route management that you need to do. You need to program these routes into VPCs, into TGW to make sure that your traffic is properly steered towards this firewall. And then when it comes to deploying it with AWS TGW, you are forced to run IPsec between TGW and the firewall. Why? Because when it comes to active deployment, you need to run ECMP, the equal cost multipath, and that requires you to run IPsec and BGP. So now you can see, although this TGW could be providing you 30 gig of throughput, but now you're limited by the performance of this IPsec tunnel, which if you count the return traffic in the picture, it gives you about 600 Mbps, right? So that's not enterprise grade performance that you get with this type of deployment. And then you talk about the source netting issues, because now you need to make sure that the active firewall who took the traffic, initial traffic, is also in the path for the return traffic as well, because you don't want to create asymmetric routing. Now you're forced to use source netting there, which again breaks your day to ops in some cases, because now you don't have visibility into the source IP, right? And then another problem of the encryption, because now you see these links, they are not encrypted by default. So these cloud native constructs are not providing you the encryption. That is, I think, is the most important thing for any security deployment that you have. Now, if you look at the example of Azure, kind of similar theme you see there, right? So there is a complexity when it comes to configuring all those static routes or UDR to make sure that your traffic is actually routed to these firewalls, and then it should come back into the same place. So there is a problem of inserting these security services or chaining those services in the flow. Then you're also kind of struggling to configure this internal load balancer ILB to make sure your policies are in place, your traffic flows are the way you want them to be. Then there are some inconsistencies. There is inconsistent behavior when it comes to high availability or the failover scenarios. And then the problem remains the same when it comes to visibility. Now, in some cases, you're using source netting, and your day to operation is breaking, and then there is no encryption. So how do we solve these challenges? So this is where Aviatrix is helping a lot of enterprise customers when it comes to deploying these security appliances or firewalls in the cloud. So with this help of Aviatrix centralized controller and distributed data plane, now we can inspect and insert the firewall for all type of traffic. Could be east-west, north-south traffic is staying within the VPCs or VNets or going towards the on-prem location, doesn't really matter. And this is all done through the encryption in place. So the traffic that is in motion is actually encrypted at the high performance level. So highest performance throughput available by these cloud native providers. The solution is all active. It's available across multiple AZs. So you have the AZ level high availability as well. And the beauty is that we don't use any IPsec, no BGP, no SNAT. So you have complete visibility into the operations. So you can use tools like a packet capture or traceroute or ping, which obviously are not provided by the cloud native providers. All this is deployed in automated fashion. So you have a centralized place via the controller to deploy these firewalls. So you're not struggling to log into these consoles and then deploying these firewalls and then figuring out how do I actually insert into my traffic flows. Controller is extremely intelligent and multilingual device, or the platform allows us to talk to multiple cloud providers and also third-party vendors like Checkpoint, Fortinet, and Palo Alto. What we do, we basically take care of all the UDR and route propagation. We also take care of any routing that Saad was mentioning before. If you have new route coming in from on-prem or from a different location, we know about that. With all the proper ActiveMesh controls in place, we can sync the route, we can push it to the firewall based on the traffic that you want to inspect. What we have done with 6.0, we have also improved the health check monitoring of those firewalls and the gateways. So prior to 6.0, we used to monitor the health through the firewall management interface, but now you have multiple options available. You can also monitor the health of these firewalls using the LAN side, which actually improves the performance or the failure detection significantly with 6.0. So now if the firewall goes down or the gateway goes down, we can quickly and automatically rebalance the traffic and take it out of the path and then send it to the other available firewall in the picture, as you can see. Another enhancement we made, and this is, I think, is a extremely important one, is that now we have this dual transit FireNet support. So in the picture, you can see that we have spoke VPCs, the green and blue, and now they are actually connected to multiple transit. So this transit is the east-west transit FireNet with the firewalls in there, and then we have the egress FireNet with the firewall. So now it allows our customers to quickly segregate the traffic based on where it needs to go. And it actually helps them in achieving the compliance, PCI or HIPAA or whatnot. Because this is now controlled through the intelligent controller, which automatically detects that if this traffic, it needs to be inspected inside the cloud, then it will be routed or punted to this transit VPC FireNet here. But if it needs to go out towards the internet, we will automatically send it to the egress transit VPC here to get it inspected through these firewalls. So now you can see it helps you divide or segregate the traffic based on the traffic profile or traffic type that you're sending from your spoke VPCs. Everything that I talked about is all policy-based service insertion. So like I said, it's just extremely simple and easy. The network segmentation that I talked about, all those concepts and all those features are applicable here. So it's all about creating those policies using the controller, or could be a simple Terraform, and then applying it to your workload. You can go one step even further. Now we have this 6.0 feature, which allows you to selectively exclude some CIDRs from being inspected. So let's say this prod VPC or some shared services VPC is what you need to inspect with this firewall. But in the shared services VPC, you have, let's say, Aviatrix controller or Copilot, which you don't want to be inspected through these firewalls because you don't want to break or block this traffic right? So with this selective CIDR exclusion, now you can create granular policies at the micro level, which allows you to exclude that type of service or servers from the inspection. All right, so what are the next steps? So you heard a lot about Aviatrix 6.0, and we are kind of giving you this preview before our launch tomorrow, because we want to give you this advantage being ACE is there. So now if you are interested in knowing more about any of these features, you can actually set up a call with us. It could be a 30-minute call where we can show you all of this in action, or maybe you have a need for one specific use case. Or you can schedule a virtual design session. So if you know exactly what you want to deploy and design, we can actually help you in terms of designing your solution. I know you guys are all ACEs, so at least you are at the level of ACE associate, but if you need to go towards the next level, which is ACE professional or ACE design associate, please, design architect, sorry, please send us your queries and your request, and we will take a look into them. So like I said, Aviatrix certified engineer track has 3 different levels. The associate is the beginner level, then professional is the mid-tier, and the architect is the last level. So we have online and self-paced offering for ACE associate. The professional ACE is basically based on the request that we receive, and there is a mechanism and a logic that we follow to allow our customers to join those professional sessions. So if you want, or if you are interested in it, please let us know. With that, want to say thank you, everyone. If you want to know what is coming up next, what other events we are offering, please go take a look at this link here, aviatrix.com/events, and definitely join the community, join the movement, and ask your technical questions, and then help others as well in terms of their knowledge building in multi-cloud network space.
So before we let you go, Aces, I mean, I really wanted to thank you for such an interactive session, right? I mean, there are so many questions you guys ask, and I wanted to thank all our panelists as well. They have answered all the questions, right? So I mean, if anyone has any question, this is the opportunity for you to ask any questions. Besides that, each one of you already have received an email from Aviatrix to accept your verified badge, right? And this is via Acclaim. So one request for you is to just please accept and proudly display this thing on your LinkedIn or any other social media. So if there are no other questions, then that would be a wrap. I think we are still getting 1 or 2 questions. Yeah, go ahead, please, Tom.
Yeah, this is Tom. Hey, there's still a couple of questions that are open. If we can just leave this up for a few more minutes so we can just make sure we address all the questions before we close out.
Yeah, no problem. And I mean, if you wanted to answer those questions live, you can do that too, Tom, or anybody, any of the panelists.
Okay, thanks, Todd.
Maybe there's a few, hey, this is Nicholas. There's a few questions we could share here that have been asked on the Q&A, but I think are interesting to share with everybody.
Sure, Nicholas, go ahead, please.
Yeah, there was one question about the multi-cloud segmentation domains that you, Shazad, has explained, and the question was if it requires a third-party firewall to work. And so response is no, it does not. There's no dependency on the Aviatrix multi-cloud segmentation domains to any third-party firewall. The segmentation is performed on the transit gateway, but you can of course use that and insert the firewall between the segments or within the segments.
Yep, that's a very good question. So yes, so in this diagram, you don't see any firewall here. So that could be your level of defense or the security level that you start with, where you color those segments, you create the security policy, and then you define if this traffic is allowed to talk to other color or other segment or not. And next level could be to use or utilize those firewalls. But the beauty of the solution is that everything actually works in conjunction. So you can use multi-cloud network segmentation plus the FireNet to protect the most important workload that you want to protect.
Yeah, and just the last one for me. So Kevin Goose, you know, you've added quite a few questions in the Q&A here. If you could reach out after this webinar, let's have more of a detailed kind of a whiteboarding session with what the particulars of your question are around your internet application going to the internet and, you know, using multiple sources and destinations. I don't believe this is going to be a problem, but I think it's worth just having a further in-depth conversation on it.
Thanks, Tom. All right, so any other panelist has any other question or any comment?
No, thanks everyone for your time. I think all the questions have been answered. If there's any other questions that you guys have after this session, please reach out. We're happy to set up another call.
Yeah, or you can use community to ask your question there. So we will be there answering questions, and we'll take it if you have a very specific need. So like Tom and others said, we can set up a one-on-one session with you and go over those unique requirements.
Right, great. Thanks again, everybody. And that is a wrap. And we will, pretty sure we will get in touch with you guys. Thanks.
Thanks, everyone.